We have an exciting day of content for you. Keynote will also take place on this stage. But we're about to kick off with our first speaker, who is MongoDB Field CTO Rick Hulahan. And the talk is going to be from RDBMS to NoSQL at enterprise scale. So if you could all put your hands together and give a very, very warm welcome to Rick Hulahan.
Hello, everybody. Thanks for taking the time out of your day to come here. Us talk a lot about MongoDB. You'll hear a lot about our product today. And my name is Rick Hulahan. I'm the field CTO for enterprise here at MongoDB. Some of you may know me. I have a long history in NoSQL technology. I was the worldwide technical leader for NoSQL services at AWS. I was actually the first enterprise SA for DynamoDB. But probably my most relevant experience came when I was working with the Amazon retail team on a small little project we called Rolling Stone, which was really about the deprecation of the relational database for all tier 1 services at Amazon. I actually led the black belt team for NoSQL technology at Amazon during that project. That's really where I developed a lot of the program that I run today for MongoDB, which is about enabling customers to understand how to use NoSQL technologies and document database technologies efficiently to solve their problems, right? And that's really what it comes down to is, why did Amazon choose a NoSQL database? And what it came down to was the efficiency of the system, but it wasn't really the mission we started with. And so how did we get to that place, right? Why does a decision, what leads an organization like Amazon to make that decision? And it really is the same decisions or same criteria that any enterprise uses to make that decision. We'll talk about that in a second. But a lot of it was finding that path, right? How did we find that path to that, what we call database freedom, I guess you'd say? How do we blaze that new trail and get 25,000 developers around the world at the time? This was in 2016, 2017. They're probably twice that many now. But how do you get all these developers in a global organization kind of marching to the beat of a new drum, understanding a new technology and using it the same way that they've used the traditional relational database for decades, which was their go-to, right? And what it came down to make that happen was to make it work was about modeling relationships. I always like to say there's no such thing as non-relational data. Right? I don't really use that term unless I discuss exactly that there's no such thing as that, because if we care about the data, it's relational, and I need to model the relationships in the data efficiently to use the database, right? So the bottom line is modeling relationships in NoSQL is a fundamental skill that developers lack today, and that's really what my team helps people do. And when it comes down to it, it's how do you execute that plan, right? How do you manage a technology transformation at that scale? And this is really what my team does today. It helps our customers execute those types of transformations and install the skill sets they need to be successful in doing so, right? So what does it look like to make that happen? So again, the first thing we'll talk about is Amazon, right? Why did Amazon make that decision? And what it comes down to is about change, right? Change begins at the edge of your comfort zone. If you feel good about what you're doing, if you feel comfortable with what you're doing, then you're not really changing much, right? The more you change, the more uncomfortable you should feel. And Amazon itself was not really born in the cloud, right? Amazon, a lot of people think it was easy for us to make that move because, aren't you guys all built on AWS? Well, the reality was Amazon was founded in 1995, right? It was a decade before the cloud was born. We were a $5 billion company before SOA even became a standard within the organization. So we were built on monolithic services, just like every other enterprise, at that time. And by 2018, scale was breaking everything, right? We were breaking our relational database. We were the largest Oracle license in the world. We had 3,000 Oracle RAC servers or Oracle instances. We had the largest Oracle RAC deployment in the world. And really the bottom line was, and I kind of think that the reason we kind of embarked upon the path of dethroning Oracle within the enterprise was really because it was embarrassing. Right? It really didn't have a lot to do with the performance of the system at the time. We actually, when we started the mission, it was really about lift and shift. We were going to take everything out of Oracle. We were going to move it into RDS instances. We had just released Aurora MySQL. We felt that with Aurora Postgres on the horizon, we had everything we needed to scale to support the workloads we needed. But along the way, we found something interesting, right? The cost of the relational database was actually a very big line item. For most enterprise organizations, it's one of the largest line items on the IT budget. but it didn't really have to be, right? The reality of it is that there's a high infrastructure TCO associated with the relational database. The teams that were going down the NoSQL path were having better results and were driving a lot of efficiency in their workload. So we started looking at this and thinking, maybe there's a better way, right? And really what it comes down to is history, all right? We weren't born with the relational database, right? When you look at the timeline of database technology, it's about a series of what I call peaks and valleys in data pressure, right? The ability of the system to process the amount of data that we're asking it to process in a reasonable cost or a reasonable time. When one of these dimensions is broken, it's a technology trigger. And we invent things, and we've invented many things over the years. So like I said, we weren't born with the relational database, we were born with a great database, the one between our ears, right? Highly available, when my eyes are open, it's online, right? But questionable durability, single user system, zero fault tolerance. We're not going to build enterprise services on this, so we started doing what? We started writing things down, storing structured data in ledger accounting systems and things that were manually collating the data. Essentially the first database, right? The first way to store structured data for people to use in the future. But this didn't scale. When we got to the 1880 US Census and Herman Hollerith was tasked with processing all of this data, right? He had to invent something new because it took him 8 years of that 10-year cycle, and he knew in 1890 it was all going to break, so he invented the machine-readable punch card and punch card sorting machine, and the era of modern data processing was born, right? Along with a small little company called IBM. The large and storied footprint on data processing technology over the years. The reality is we start to push the edge of the system, we start to invent something new. We pushed the edge of this system very quickly. We invented paper tape, magnetic tape, distributed block storage, random access file systems, hierarchical management systems. These were all precursors to the modern relational database, which was invented in the 70s by a man named Edgar Codd, who had a very specific mission. When you read the paper that he wrote, his mission was to allow people to ask questions of their data without understanding how it was structured on disk, right? And the biggest criticism of the relational database was that it was a high overhead process to join tables, right? Joining tables is a merge sort, it's OM plus N, right? The hierarchical management systems of the day, they collated information based on the process that they were serving, and they could do it with O log n time complexity, and we'll break this down in a second because they're just looking up data on indexes, but restructuring the data, answering the ad hoc queries. Oh, you had to write code, you had to understand how the data was stored, it was very difficult. Edgar Codd was a mathematician and he was faced with a problem, right? The problem was that the CPU bandwidth and the storage throughput at the time did not allow you the idea of running ad hoc queries. It was fantasy land, right? You could never do it. Well, fast forward 30, 40 years, we'd have a different problem, right? Two things occurred. Moore's Law came along and it was the friend of the relational database. It made the pain go away. And really that criticism that it would never be suitable for OLTP workloads, well, the cost dropped to the point where it actually was. 30, 40 years later, not so much. And also now we have the CPU bandwidth and the storage throughput to do something different. Okay, so if you look at it today, Moore's Law is no longer the enabler for the relational database that it used to be. This is really what drove the decision for us at Amazon. When you start to look at the time complexity and the overhead of the relational database, it becomes obvious when you start to look at the trends in CPU processing power. On the left-hand side, we can look at the annual performance increase of the top 500 supercomputers. All right, these people are investing in every single thing they can to drive their performance as much as they can, and they have not been able to hit Moore's Law performance gains since 2014. Okay, probably really around 2012 is when it broke. That's over a decade. Okay, so it's slowing down. Meanwhile, you look at the gate cost, it's increasing as we start to decrease the fab size. This has been a trend that's going on for decades. It's getting more expensive to get smaller, right? And at the same time, we're seeing CPU performance flatten on a per thread performance basis. The only way we're getting increased performance is through parallelization. And there's a decreasing rate of return on that, and we all know this. There's overhead associated to that. It just increases as you start to increase the number of threads or number of cores. The reality is cost of storage continues to fall. And this has really always been the trade-off between the relational database and the NoSQL database has been the cost of storage and denormalization versus the cost of compute. And as long as that ratio remained in the favor of the relational database, then it made sense. But the reality is today that that is not the case, right? And this is not new thinking. This is not just me talking about it. These were the same concerns they had back in the 70s and the 80s when the relational database was introduced. Edgar Codd himself talks about these things when he talks about the cost of normalization, the benefits of normalization, when he talks about the deduplication of data on disk, right? The ability to reduce the amount of bandwidth to consume to transmit large data sets because of normalization. Again, he's a mathematician, lowest common denominator solutions. But he himself recognizes that if you introduce strong redundancies into the stored set, right, the ones that exist in the name set, what's he talking about? He's talking about denormalization here. You will consume extra storage space, but you will reduce the time complexity of the queries that are running in certain cases, okay? In the ones that it's optimized for. Well, the bell went off at Amazon when we started thinking about this. The reality is the queries that are running 1,000 times a second, those are the ones I care about, right? The ones that are running like once a day, once an hour, at a much slower pace, I really don't care if those are as efficient as they could be. But the ones that run 1,000 times a second, boy, I want those to be really, really efficient, okay? So the other thing that Edgar Codd talks about is the cost of normalization. Don't over-normalize. As a matter of fact, he recommended back in 1975, and we all did this in the early 80s, is that if the data is immutable, then don't worry about joining it in there. That's too expensive. Denormalize it. The cost of storage is cheaper than the cost of the join. This was true in 1980. It's actually always been true, but the cost of the join became less because of, again, Moore's Law made us more efficient. It was like Tylenol, right, for the relational database. In the beginning, it was a big headache. We had some Tylenol. A couple of years later, it's wearing off, right? And there's nothing that's going to replace it. It became less effective. So the question now becomes, when do I look at NoSQL technology, okay? When should I use this more efficient platform for supporting my workloads? And what it comes down to is that, it really doesn't matter. It's not about NoSQL anymore, right? Even NoSQL databases like MongoDB, which support SQL APIs on the back of MongoDB Atlas, right? We have an SQL compatible, an SQL 92 compatible API. You can connect to it with ODBC. You can run the tooling that you're familiar with. Yes, it might run on a denormalized data model. The queries might look a little different, but your data analysts that are familiar with SQL, they're going to love this just like they love their relational database. So today it's more about normalization versus denormalization, right? When do we normalize? When do we denormalize? Well, the bottom line is if I don't know what questions I'm asking, if all I need to do is support ad hoc queries, then it's probably a good idea to normalize your data, store it in a relational database, because that's the lowest common denominator of data. But the reality is 90% of the workloads that we write code for, they're automating OLTP processes, right? The last thing we want to do is normalize the data in that case. I would rather skew the data towards the most frequent access patterns to drive efficiency in the system, as long as I can support the more complex access patterns, right? And this is really the crux of NoSQL data modeling. This is what we work through with teams when I meet with teams with our customers and we drive our design reviews. I think Andrew was over there talking about what makes a good design review earlier, but it's about understanding your workloads and mapping the data model to the access patterns most efficiently to drive the infrastructure cost down. And believe me, we can drive the cost down quite a bit. The relational database, again, it's an order of magnitude less expensive to run an O log n query versus an OM plus n, and we'll break that down in a second. But the bottom line is, I love this quote from Mark Twain because it reminds me that maybe he was a time traveler, right? He actually was one of the first investors in the linotype, which is early data storage technology. It was replaced very quickly made obsolete by the machine-readable punch card and the punch card sorting machine. But the data is like garbage. You better know what you're going to do with it before you collect it, right? And this has never been more true than it is today. But the data, it's all about relationships. We talked about this earlier, right? The bottom line is there's no such thing as non-relational data. No matter what application I'm building, I need to be able to map the relationships of the data efficiently so that I can query the data effectively and do it at a reasonable cost. Whether it's social networking, document management, IT systems management, you name it, there's always relationships that the data needs to be expressed in the data. And in NoSQL, it's about modeling the data appropriately because access patterns drive your cost, okay? At Amazon in 2017, when we broke all this stuff down and we looked at what we were going to be doing, 70% of the queries that ran across the 10,000 services that we moved off of our Oracle RAC deployment were actually accessing a single row of data, okay? 20% more were accessing a range of rows from a single table. I find this to be very consistent across the services I work with the customers that I work with, because OLTP workloads, they work with data in bits and pieces, okay? But oftentimes up to 50% of the infrastructure deployed to support the service was there just simply was being consumed by the last 10% of those queries, right? The things that said join, because that's when the CPU in your system goes nuts, right? And when we break this down, it becomes pretty obvious what's happening. Let's look at a product catalog schema. As a developer, you probably would never store your schema this way, but it's a perfect example of over-normalization, because what I've done here is I've created a products table, a one-to-one relationship between each type of product, a one-to-many between albums and tracks here, a many-to-many between videos and actors, so all the common relationships that we could expect to see in a relational database. But my access patterns don't line up to this, right? The access patterns say, get me product by ID, get me product by category, sorted by price, filtered on this condition. They don't ever really work with the data in bits and pieces, in rows on tables, right? I'm working with this data as objects, so I would probably not store the data this way. I would probably want to store the data in a database that's going to structure the data the way that it's actually accessed, because the overhead of joining the data on all those rows is a lot lower than the overhead of looking up documents that are pre-joined versions of those rows, okay? That's what the bottom line is here, and we can break that down in time complexity. It becomes obvious when you start putting data on those tables, and you start running these joins, and you start looking at what's happening from a time complexity perspective. Again, it's O log m plus n to do the merge sorts across the indexes. You could say O log n plus O log m, because, you know, it's their indexes on those tables. Regardless, it's a significant amount of time complexity to join the two tables. As we start to join through more than one table, it increases the time complexity. As we get into the many-to-many join, it starts to become fairly significant. And if, as a DBA, you got to be looking at this and going, but that's the simplest SQL I might see in my system, right? The reality is you're joining rows across all kinds of tables through many-to-many relationships and creating derived tables, and the time complexity of this stuff is just crazy. When we start thinking about what you're doing to the CPU when you write these complex queries, right? You're hopping all over the place. Imagine you're the request and you got to go get the data from all these tables. You got a big bag on your back. You don't want to go to multiple places to get the data. You don't want to get more data than you need, right? You want to go to one place, get what you need, and be out. And that's what NoSQL does. When we look at model joins in NoSQL, it's a different story, right? We take documents. This is a document modeling convention that I built over the years. Essentially, at the root of the document, we have the unique identifier. In this case, I'm going to use a useful value. Oftentimes, we see object IDs auto-generated in the system that are used as underbar ID. There's never a read pattern on that. So essentially, you're creating an index on an attribute that never gets read. That's a dead space on your disk, a dead space in your memory. So always have a useful value. If a customer has like a PO number or a job ID or something that's guaranteed unique, right? Use that as the underbar ID. You don't have to let us auto-assign it, but always have a useful read pattern there. So in this case, I'm using the title of the book. I like to decorate my documents with the type attribute because that tells me what it is at a glance. The data sub-document, these are like the columns on the row, right? The data that I'm interested in when I go select this object. It's an embedded sub-document, and then I'm going to have indexed attributes at the root of the document. In this case, I've got an array of target pointers that are indicating when I read this document what else I'm related to, right? There are many documents in this collection of different types, they're different relations. I'm related to my publisher, I'm related to myself, the book, related to the author, related to various entities that have some sort of relationship with this document. Again, there's no join here. It's a single key value lookup, so it's O log n. As we get into the next document type would be the album. Similarly, right, we have target IDs pointing to the other documents in the collection that we're related to. We have some data that describes the album. Time complexity O log n. This was the one-to-one to one-to-many. Now we're down into the many-to-many time complexity O log n. Again, orders of magnitude lower than what we're looking at with joins. And I'm getting essentially all the data I need here. I'm getting the data about the actors I'm related to. I'm getting what the roles those actors played and whatnot. But in the real world, it's nice to talk about key value embedded documents. But in the real world, like I said, these things, we work with rows on tables, but we join them when we want views, right? So how do we create those types of data structures? And what comes down to is this target array. If we think about this, if we put all these documents in the same collection, let's add more dimensions. We'll bring in the authors, we'll bring in the actors, we'll bring in the song documents, we'll bring in all the other things that these documents are related to. We're going to tag all these things with their relationships to the other objects in the table. And now when I index the target array, I get this multi-key expansion that essentially shows me what documents are related to each other and allows me to query those documents with the low time complexity. So in this case, I can say, get me all the books written by Mary Shelley. It's going to be time complexity O log n. There's no join between the author and the books table, right? As I go get me, all the albums the song has appeared on, all the musicians that performed it, everybody that was related to it, the writers, the studios, whatnot. Actors might be producers, directors, right? I could filter on the types of relationship. Again, look at the time complexity, it's O log n. I'm joining objects here. I'm taking objects that are related to each other and I'm producing a result set of multiple documents that if I stored these on different collections, like I did in a relational database, now I got to go to 2 places and merge sort these indexes. In this case, it's all O log n. Even when you get down to that movie join, right? We get down to the very end of and we're joining the movie, all the actors, the cast, the crew, the directors, the producers, right? The studio that recorded it, everything. If you want to get a full join on every entity related to the movie, I can do this with O log n time complexity. Again, so this is a simple example that probably is not representative of a real world workload, but it demonstrates exactly how you can drive efficiency by joining objects that are co-located in the common collection. And when we work with our customers, this is what we'll do. We'll break down your access patterns. We'll understand exactly what type of document structures you should be building. Are you a write-heavy workload? Are you a read-heavy workload? Should we split the documents? Should we embed the documents? These are the skills that your developers need to make good decisions about the technology they use. Right? Today, we all default to the relational database because it's what we know. Well, once we know how to do this, all of a sudden, the world opens up for us and things get a lot cheaper. Okay, I talked to teams today, 5 years later, at Amazon. They're telling me they're just hitting the spend rate that they were running at in 2017, 2018 when we moved them. That's 5 years of growth, right? 5-6 years of growth that they've undergone without spending an additional dime. As a matter of fact, spending a hell of a lot less for the first 5 years, right? So enormous savings we can drive, and it's measurable when you model the data correctly, okay? And again, that's what it comes down to, modeling things correctly. We had lots of good information, but those plans are good intentions, right? Until you actually break it down into hard work, and that hard work was hard. What it came down to was trying to teach people how to do this wasn't easy. And it came down to this effect. If you look at the bottom of this chart, that's the technology adoption curve, right? As we have some technology trigger, in our case it's data pressure, where you see the innovators come up with new solutions, NoSQL document databases. They have great results. Other people run to use this technology. They have miserable experiences. Why? Because most often they didn't really learn how to use the technology, or didn't have the opportunity, or the knowledge wasn't really defined to be distributed, whatever it was. They have this inflated expectation, this miserable experience. But as the early majority arrives in your organization, understanding how to use the technology, now we start to have this slope of enlightenment, right? Where we hit this plateau of productivity as we get out to the end. So the relational database today, right, it's out on the right-hand side. But, the bottom line is, if you don't know how to use it, I can't help you. But the NoSQL database today, maybe we're kind of getting to the early majority, but we're not there yet. And that's where my team comes in and tries to help people solve their problems. And the best example would be when we work with the Amazon shopping cart, right? Shopping cart service, we all use the shopping cart service, right? We all use it kind of like a database. You add items, you remove items. A week later, you go buy something in the cart. Oh, I don't want that, I don't want that. And the shopping cart team came to us and said, we can't use this technology, right? It's too slow, it's too expensive. And the reason why was because they were creating a single document and they were adding items into it. The shopping cart items are a little big because they contain small images and things like this, because binary objects that are essentially bigger than maybe you might store. But in DynamoDB, they had this minimum WCU cost. Storing them in S3 was a little more expensive. Small objects, high volume requests, not cheap. So they went ahead and stored it in the DynamoDB table. It's about 1 kilobyte of data for each item. As you add items to the table, it's 1 kilobyte, 2 kilobyte, 3 kilobyte. All NoSQL databases suffer from this disease. Dynamo, it's immediately apparent because you get charged by the size of the item. So they're essentially growing the document. If you think about how the shopping cart actually works with the data, it works with rows on tables, right? You have a shopping cart table, you have a shopping cart items table. As I push and pop rows on and off that table, I'm working with smaller chunks of data. So the relational database was actually more efficient than the structure they built. So how do we solve that? We solved that by storing multiple items on the DynamoDB table, right? One for the shopping cart, one for each item on the table, and using the partition key as the shopping cart ID and the sort key as the ASIN or the SKU, right, which then the shopping cart item had a SKU of 0. Now I could select the entire cart by saying where partition key equals shopping cart ID, right? I could select individual items and work with individual items on the table, but I was able to, because all the objects were stored in one collection, essentially we collapsed those tables into a single collection. Now all of a sudden the efficiency of the join was driving efficiency of the service. And they came back and said, wow, now we're saving like 70%, right, of their cost, right? Because all those little one item, adds and removes weren't hurting them, but the joins were. So again, understanding how the technology works gives your teams the ability to make good decisions, right? Otherwise you make bad decisions, you have bad experiences, and you think the technology doesn't work when it actually really does. And this is what we do for our customers. My team, we focus on what we call MongoDB Day, Developer Day events. We work with our customers, show up on campus, we break down workloads, we go through design review process with individual teams, individual workloads, and it is about a detailed exploration of NoSQL data modeling. Right, how do you do this for your workloads? We found that to be the best way to teach people, right? When we had sandbox events and brown bags and all this, but they didn't teach people as much as they needed to know to solve their problem, right? They taught them how to solve a problem. What we found was developers actually learn best when they're solving a problem they have context in. And that's where NoSQL data modeling is really applied. It's applied in context of the workload that you're working on. So we turn that into the workshop. And this is really what it comes down to, is this design review is the goal here. We want to come in, meet with your teams. We'll do the brown bag events. We have workshops. We'll teach you how to do the coding and all this, and those are great skills you need to know. But the one skill that we'll leave you with is the ability to actually model the data for the problem you're solving on, and we'll do that with these 1-hour whiteboard sessions. Typically, day one is about the content that we talk to, like I'm doing here today, workshops, whatnot. Day two is individual meetings with individual teams, not a large time commitment across the org, just individual teams for an hour, where we talk about their workloads, we break down their problems, and what we leave them with is a prototype of a document model that they could use to iterate on. I treat these as enablement services, right? We don't actually sell things. It's a very effective sales tool because the technology really does work, and when developers understand how it works, they make the decision more often than not to use it. But from my perspective, I don't care if you're talking to me about a workload you're working on, something that is already in production, something that will never move to MongoDB. I want you to have the experience of understanding how would I have done it, so that the next time you go work on something, you say, wow, I think I understand how this might work, and you make a different choice. That is my goal, to enable your teams to have the skills that they need to succeed, right? And beyond that, if we are effective at selling the product, that's great. The company wins, the customer wins, and that is exactly what we're trying to do here, right? And it's one of the things I love about MongoDB. I mean, my whole career here, this is my second tour. The reason I'm back is because that's the way it was when I left. It's the way it is now. We want our customers to win, and we want to win, right? So what to expect from this are really discussions focused about driving efficiency, data modeling, and NoSQL. We'll use your workload as the platform to have a discussion. We'll tweak the parameters. I'll say this is what might happen if the write velocity goes up. This is what might happen if the read velocity goes up. These are what those models might look like, and these are why. And again, that exploration is just solid gold for developers because it's in the context of what they know, of what they're familiar with, and they learn better. So how do you book these things? Talk to your account reps. If you're one of our customers already, you're going to have a developer center already in place for your company. You can QR code right up there. But reach out to your account rep. Find somebody here on the floor. How do I get involved in the design review program? Our whole developer relations team is executing these, not just the strategic account team that I run, but our whole DevRel team. So even if you're a small customer looking for guidance, it's a great place to start. Again, and one of the tools we bring, I only got a minute here, so I don't have a lot to talk about this, but the relational migrator is there for you as well. You go through one of our design reviews, you come out with the document model, you've got an existing data set you want to migrate, you can configure that model into that relational migrator, and it'll help you move that data. Definitely talk to somebody on the team about this. But again, conclusions. If you walk out of this session with anything today, understand NoSQL is not non-relational, right? All data is relational. The ERD still matters, right? Relational database efficiency is declining, right? It'll scale if you put enough money into it, right? It will scale, but I can do it faster, I can do it better, I can do it more efficiently with NoSQL. It's a great fit for most OLTP workloads, and it also, the API MongoDB supports OLAP just as well. SQL 92 compatible API, aggregation framework, a lot of flexibility you won't find, right, in other NoSQL databases. So thank you very much. I appreciate your time, and please enjoy the day. And oh, by the way, we have these, oh, I don't have a QR code. There's supposed to be a QR code in there, but there's not. So if you do get a chance to put feedback on the session, please do. Otherwise, if you didn't like the session, there'll be another QR code someplace you can scan and give that feedback. So thank you very much.
Rick Hulahan, everybody. Thank you very much, Rick.